So ladies and gentlemen, please welcome Daniel Coulbourne on stage. Thank you.
Woo! That's me! How we doing, everybody? How is everybody doing? It's great to be here. How are you all? Good? I'm glad. That was crazy. You guys have a lot of energy. I'm Daniel Coulbourne. Thank you for having me out to Laracon, India. This is now my third Laracon. So I did Australia in November, and then I did Laracon EU just last month in Amsterdam. And now this is my third Laracon here in India, and then in August I'll be doing Laracon US. So I'm really excited. I'm trying to hit them all, catch them all like Pokemon. Let's see if, hey, it works. So that's me. That's my Twitter handle. I'm just going to leave it there for no reason. You can do whatever you want with that. But yeah, I'm one of the founders of Thunk.dev. So Thunk.dev is a small Laravel consulting company. We do sort of product-based dev consulting. And this stopped working? Oh, no, it didn't. All right, cool. That is John Drexler. So John is my co-founder at Thunk.dev. This is actually a screenshot of Joe's event in New York City, where John gave a talk about product management called, I don't know, Only Solve Problems or something. But John is always asking the question, what problem are we solving right now? And he really helps us figure out what we're trying to build for our clients and what problems our clients are trying to solve. And then I help them actually build them. Verbs. So Verbs is a event sourcing package for Laravel that we built at Thunk alongside help from my friend Chris Morell. And it is a package that we use internally for a lot of our clients, and we think it's a really interesting and good way to build Laravel applications. And so we're trying to make building Laravel applications using event sourcing accessible to everybody. Oh no, there it is. So this particular story is a war story. This is a story about a real situation that actually happened, a real project that I actually worked on. And it's a story about a project that was not perfect, right? It was a mess, and like most real projects, it required us to deal with the nasty realities of the world. So legacy code. Everybody has legacy code, right? Who here doesn't have any legacy code? That's what I thought. You all have legacy code. You know, some people will say, I don't have legacy code because all of my code is tested, and legacy code is untested code, and I have tests, and so I don't have any legacy code. I think it's a lie. I think legacy code is any code that you hate. Who here has code that they hate? Yeah? All right, me too. I have a lot of code I hate. So this is my buddy Caleb Porzio, and he was recently speaking on an online conference, and he said that legacy code is any code that you resent. And that really struck a chord with me, and it felt very true to me. When I think about the code, I onboard into projects all the time. I've probably onboarded into 50 projects in the last 10 years, into 50 different code bases, right? And every time I get there, there's some code that everyone hates. And they say, oh, we built this 10 years ago, it works, we wish it didn't exist, but it does exist, etc. Devs know where the bodies are buried. So every code base has some buried bodies in it, right? Every code base has some sins of the past that are covered up by Git. Every code base has, you know, some procedural PHP, maybe some 10,000 line files, maybe a dbconnect.php running on a server from 10 years ago. This is the real world, right? If you live in software development long enough, you'll find out that any company that's really making money has some old code that looks like this. And fortunately, we all know how to deal with legacy code pretty well, right? So you can just take your legacy code, You write some tests around it, right? So you say, here's some tests that prove that my legacy code does what it's supposed to do. And then we can just start refactoring and make those tests continue to pass, and eventually rewrite all of that legacy code into new code that we like and doesn't feel quite as bad. But legacy data is bad. So legacy code, it's easy. We test it, we rewrite it, we make it good. But legacy data is hard because you can end up with a database with millions and millions and millions of rows of old data that's in a bad shape. And it's really hard to deal with that legacy data. So sometimes I'll get to a project and I'll start looking at their database and they'll have these columns. And I say, what does this column do? And they're like, I don't think we use that column anymore. And then I'll say, okay, that's fine. But what about this table over here? What does this table do? And they're like, so we might use that table? I'm not exactly sure. We'll have these magic strings. So we'll have a column full of, usernames that are referencing the user table. So they're not using IDs, they're just using magic strings to reference relationships between things. I call these situationships, right? So anything you can do to avoid a regular old relationship. These are big, bad, nasty schemas, and I've seen them so many times. Hundreds of tables, half of them unused, half the columns in those don't do what they say they do. Has anyone experienced this? Yes, all right, good. You're real developers. Refactoring legacy data sucks. I've done it a lot, it's terrible. But there's a few popular approaches to dealing with legacy data. Trash it and start over. This is my favorite one. If you can do this, you should do this, right? Because all of the other approaches are worse. If you can delete all of your data and start over, I suggest it. But we can't always delete all the data. Sometimes we have to keep the data. So compatibility layers are another popular approach. So Stripe actually does this. So when you make an API request on a newer version of the Stripe API to Stripe, but the data was stored on an older version, that data is actually going through multiple data transformers to transform the data live into the format that you requested, right? And so data transformers or compatibility layers are one potential solution to sort of legacy data structures. So you keep the data in the old structure, but you present it to the user through an API or whatever in a different structure. But that doesn't really solve all of the problems, right? If you want to write good queries, you need good schema. So inevitably, there's only one real solution, and this is the heroic data migration. Does anyone know what I mean by a heroic data migration? Right? This is the one where everyone says, okay, well, why don't we all wake up at 2 in the morning, and we'll all get on a call, we'll all get on a Zoom call together, and we'll just kind of sit there, and we'll check everything, and hopefully if something goes wrong, it'll be 2 in the morning, so not that many people will be online, and we can maybe hopefully fix it really quick. I've been on 20 of these calls. I hate them. They're not fun, they're scary, and sometimes something goes wrong. And sometimes when something goes wrong, you can fix it. But sometimes when something goes wrong, you can't fix it. And that's really scary. But all of these things have a moment where you flip the switch, right? You go from the old way, where all of the data was in the old schema, using the old access patterns, to we're switching over to the new database with the new schema, we imported everything, blah, 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 and now we're on the new system. But as soon as you flip that switch, things start to matter, right? So new data is getting created and put into your new system, which means if you have to roll back to the old system, you're going to lose that new data. Anyone ever lost new data because they had to roll back to the old system? Yeah. There must be a better way to solve this problem. And I thought so too. So this is a true story about a real situation that I encountered on a project I worked on probably 3 years ago. So I worked at this company, and this company had one server that was bad. The whole rest of the company was Laravel apps on these good Forge-hosted servers with, load balancers, and we had, redundant, like read replica databases. It was a really well-architected system. And then there was this one server called Hosto. And Hosto was the server I was talking about before with the 10,000 line files and the dbconnect.php and all of the problems. And there was one big piece of Hosto that was really important to the business. All of the important pieces had been slowly moved off into the Laravel app, except for this one last piece. And so we were all sitting around. The first day I got hired, we had a long conversation about how to migrate the one last thing off of Hosto. And that was the exam system, rather, the exam system. So this company did continuing education, online educations, right? So people would take exams, the exams had questions, people would answer those questions, then they would get a score. Based on that score, things would happen. Yeah, so we have exams, we have questions, we have answers to those questions, and then we give the users scores after they've answered the questions. Unfortunately, it was a little more complicated than that because also you could retry the same exam, and then also the questions would change over time, and the answers would change over time. And then in certain cases, you would get partial credit if you answered the question partly correct. Oh, and then also, all of this data was being fed to 50 different government entities, all of whom could audit the system at any time. So the data really, really, really needed to be correct. It was a scary schema, and it got millions of hits a month. So this is a little bit what the database looked like, right? So we had we have the text of the question, we have what exam it's in, which is also a string. Then we have 3 columns called answer 1 text, answer 1 value, answer 2 text, answer 2 value, answer 3 text, answer 3 value, and then whether or not it's multiple choice. I never asked the question, what happens if there are 4 answers? So this is actually pretty common. I've seen a lot of database tables that look like this. Now you'll notice there's no relationship to the exam through an ID. There's just the name of the exam. So what happens if there's the 2022 Laravel history exam, and then next year we update it to be called the 2023 Laravel exam? All of the relationships break immediately. So you see, that's a magic string right there. We have no relationship to answers. We're just making new columns every time we need a new answer. I don't know what this value column even does. And you see over here, we have a Boolean, but it's null. I don't know what null means in a Boolean. Then we had this answers table, right? The answers table looked very similar. So at least the students have IDs. That's pretty nice. But the question is still using the question text. It's a magic string. Then it has the answer text again. Still no answers relationship. And then there's something called attempts. I don't know what they are. And apparently there's also something called points. So this is the situation we're walking into. It was something like this. I don't exactly remember. It was a long time ago. But clearly, we would love a new schema, right? And we could all sit here and think, you're all smart Laravel developers. You can think, how would I design this system if I was designing it? Well, it probably would look something like this, right? You'd have a questions table. You'd have an answers table. You'd have a responses table. So that's when a user responds to a question with an answer. And then you'd have a scores table, right? And you just have these IDs that linked them all together, and you'd use has many and belongs to many, and you'd link all your stuff together in a real nice Laravel eloquent relationship system. But we couldn't do that. Because we have 15 years of legacy data, right? So it's all great to say, like, this is how we would design it if we were starting from scratch, but we're not starting from scratch. We have to deal with 15 years of legacy data that governments care about, that are going to get audited at any time, right? So we need to deal with the old data, and we also want to build a new schema. Not only that, we don't really understand how the old system works, right? We think we understand how it's supposed to work, but like we saw those attempts columns, like what are those? What do they do? I don't know. And so we can try to migrate all of the old data to the new system, but there's a pretty good chance that because we don't understand what the old code was doing, because it's in 10,000 line procedural PHP files, and there's no tests, obviously, we don't exactly know if our migration was successful or not. Not only this, it can't go down. People are using this every day. Governments care if it goes down. It's a bad situation. So we racked our brains for months. Every stand-up, every sprint planning call, everything, every meeting, every time we talked, we were talking about this problem and how we were going to solve it. And so we just started to rewrite it like we wanted it, right? So we started to rewrite the schema that we liked, and we said, I don't know, eventually we'll have to solve this data migration problem. We know it's going to suck, but that's a problem for future us. Right now, let's write the code we want to write. Until someone said the 6 words that changed the course of my life forever. Have you heard of event sourcing? Who here has heard of event sourcing? Who here hasn't heard? I can't really see your hands, so make noise. Who has heard of event sourcing? Okay, who hasn't heard of event sourcing? All right, this is good, this is good. This is why I'm glad I'm doing this talk. Okay, so we did some learning. We learned about event sourcing. And what we learned is event sourcing is deriving the state of the world from a stored record of what happened, right? So every time something happens, we're going to put that in a big database table called events. And then we're going to be able to derive the current state of the world from those events. Something happens, an event is stored, and then models are written. Who cares? I know. Well, the interesting thing is that stored events can be replayed, right? So say I have an event, and the event listener creates a model. If I delete that model and then replay that event, the model gets created again. So replayed events can generate data in new shapes. So say I have an event, I fire it, it creates a model. I delete that model, and then I change slightly the way that it creates the model. I replay the event, the model gets created in a slightly different way. So a plan began to evolve. All right, so we're going to use these icons. The trash can is the bad, old, procedural, garbage app. And the rocket ship is the Laravel app. So, in between the trash can and the rocket ship, we created a new database table called events. So we've got the legacy system, we've got the Laravel system, and we've got a table in the middle called events. And every time we wrote to the database in the legacy system, we also fired an event into our events database. And we stored an event in that database. And then we took a copy of that legacy database, and we tried to generate the exact same data in the legacy database using that event, right? And so this allowed us to test that we understood when this event happens, what data is created in the database. When this event happens, what data is created in the database. And so every time we fired an event from the legacy system, we projected that data back into a copy of the legacy database. And we wrote tests that ensured that our copy of the legacy database matched the existing real legacy database. And this allowed us to prove that we understood how the legacy code worked. So then we did the same thing with the Laravel app. Every time something happened in the Laravel system, we fired an event into the events table. And then every time an event hit the events table, we projected out back into the Laravel database. So what this led to was this beautiful infinity symbol. It's very symmetrical, and that's how you know it's good. This beautiful infinity symbol where data created in the legacy system leads to events in the event database, which leads to data in the new system. And data in the new system leads to events in the events database, which leads to data in the legacy system, right? So this is awesome because you could literally start taking an exam in the legacy system, answer 2 questions, then go to the new system, resume that exam, and answer the 3rd question, right? And so the data was instantly available in both places. Just for another illustration, anytime an event comes into the event database, we don't care where it comes from, whether it comes from the legacy system or the new Laravel system, it's being projected out into both systems, right? So this is our source of truth. Things happen in the event system, and then they get projected out into both systems. One more time with words, because I know it's a little complicated. So step 1, we're going to fire and store events from legacy code. So that might look something like this. So here's an event called question answered. It's got a user ID, a question ID, and an answer ID. So we're going to fire that and store that in our events table. This is what our events table looks like. It's an ID, an event type, and then just a really nasty blob of JSON data. Fortunately, we don't have to care what that data looks like. So we're capturing live legacy data as events in real time. So step 2, mirror the legacy data from the events. So we're going to add a handle function to our event. You could also add an event listener somewhere else in your code if you wanted to, but we're just going to add a handle method to this event. And we're just going to write the gross legacy data into this table called mirror. Step 3, event source the models in the rewrite. So in our new Laravel app, here's an example of a controller in our Laravel app, right? So this is the exam response controller. In the store method, we're going to create a new exam response when someone answers a question. So we're going to store the user ID, the question ID, and the answer ID on that exam response model. Well, we're going to slightly modify this. I'm just going to go back and forth real quick so you can see. So we're taking this exam response create, and we're replacing it with question answered : fire. So we're saying, we're going from what should we create in the database, what noun should we be generating, to what verb happened, right? What happened? And so what happened here is that someone answered a question with the following data. So now we've created this question answered event, and you remember that we were writing all of that legacy code at the bottom. Well, we're just going to move our model creation right into the handler of this event. So step 4, we're going to test this, right? So like I said, we're taking live data and we're copying it into a mirrored copy of the legacy database. So we start writing some tests and some scripts to check that the mirror of the legacy database matches the original legacy database. And this allows us to test that our understanding of everything is correct. Now we're also testing, does the data we create in the new Laravel app create what we expected in the legacy app? And does the data we create in the legacy app generate what we expected in the new Laravel app? So we just let it run in production for a while, right? Because this is just a mirror of the legacy table. It's not doing anything. It's not hurting anybody. We're just letting real events happen and seeing if they generate what we think they should in a table that doesn't matter. Once we're pretty confident that the new events are getting created successfully, we start backfilling events slowly. So we wrote some scripts that basically took existing data in our legacy database and generated events for them. So we said, oh, we have an answer in the answers table. This means that someone answered a question at some point. So we're going to create a question answered event. And then we're programmatically checking that as we import those new events, that our production database matches our mirror, right? And so we're importing these new events, we're projecting them out, and we're saying, oh, like these 10 events that we imported match exactly. Let's try 100 more. Let's try 1,000 more. Let's try 1,000,000 more. And so we get to do it very slowly, very casually. If something goes wrong, we just fix it, try again, right? There's no consequences to making a mistake at this point. Then we get to flip the switch. You remember flipping the switch, right? Flipping the switch is where we go from the old system to the new system. But we get to flip the switch slowly, and that's the beautiful thing. We have an extremely casual, relaxed deploy process. We started with an Nginx rule that sent 5% of users to the new system and let 95% of users go to the old system. And we just talked to those 5% of users, and we said, hey, how's it going? Any problems? Are you liking it? Do you like the UI? Do you think it's good? You know, whatever. So we talked to these users. None of them had any trouble. But if they did have trouble, that's easy enough. We could just put them back on the old system. Eventually, we increased it to 20% of users. And we just waited for the support emails to come in. But, you know, some people couldn't find the button, but that's normal. So eventually, we increased it up to 95% of the users using the new system. But we left that last 5% of like really angry, evil customers on the last 5% because we don't want to deal with their problems. But eventually, when we're really, 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 really certain that everything works perfectly in the new system, we launch, which just means moving the last 5% of users onto the new system. The great news is, if anything goes wrong, even after we fully launch, we can just switch everybody back to the old system. All of the data they've been creating all along is mirrored back in the old system. And any data that they create in the old system will be mirrored back in the new system when eventually we bring it back online. All the data is backed up in events. So even if we decide our new system's schema is bad and there's something fundamentally broken about the way that we built the Laravel app, we have all the data in events and we can project it out into any shape that we desire. We also get fully auditable models with just the right amount of data. So one of the main reasons that legacy data can get so messy is that it's really scary to throw away data, right? No one likes to throw away data because you might need it one day in the future. And so you end up with these columns on your tables that you're not really using, but you're like, well, we'll probably use this one day, or we might want to use this one day. Well, the cool thing with events is like, you have this big, ugly JSON blob full of data. You can just put everything you ever might want in that JSON blob and only project out the stuff that you actually need when you need it. And it all worked perfectly, and there were 0 problems at the end. But actually, we never had to roll back in this instance, right? Like, the deploy went correctly. We didn't have to pull the ripcord and roll back in the emergency situation. But we did, for a couple of months, every once in a while, log into the old system just to make sure, hey, is all the data still here? Could we bail out if we wanted to? And we could. Oh, and by the way, this is Chris Morrell. He's so big. This is Chris Morrell, and he was my boss at the time, and we were working on this project together. This was an event source project, and we were using a different event sourcing package at the time. But we started working on this together, and we started developing a lot of opinions about how nice event sourcing could feel, right? And so eventually, years later, Chris and I built Verbs. And so Verbs is our take on event sourcing and how we think it should feel. Whoa. Ooh. Verbs is our take on event sourcing and how we think it should feel. And we think it feels really good. So all of the code that you've been seeing here, all of the event code that you've been seeing is Verbs code. And you can write that code right now using Verbs. So since the last time I talked to you, and by you, I mean the Laravel community as a whole, not you in India. But since the last time I talked a month ago, Verbs is now in production in multiple apps. So at Thunk, we've shipped it into production in 2 apps. Chris and his company, Internachi, have shipped it into production in 1 app. I know of 1 other person using it in production right now. Verbs is new, but in the last month, Vishtal asked what has changed in the last year. I'll tell you what's changed in the last month. Verbs is in production. And I think we're ready to call it a beta. You know, for a long time, we had this little thing on the homepage that said, please note, Verbs is still in alpha and should not be used in production until the 1.0 release. We're getting rid of that little notification because we're seeing it used in production pretty well. The main problem that's stopping us from calling this 1.0 at this point is that we haven't seen enough volume of adoption in production for us to be confident saying this is a 1.0, we're ready to deal with hordes of support requests from millions of people right now. But if you're brave and cool at the same time, you can run this in production and we'll help you. Brand new, better Verbs documentation is launching today. So we have rewritten the Verbs documentation from the ground up. So the original documentation for Verbs was written sort of piecemeal as we built features, and it didn't paint a holistic picture of how to use Verbs well. And most of the best practices for how to use Verbs were developed in our own internal apps. And so we've now been documenting some of those best practices, and we think the new docs are really good. So later tonight, we're pushing the big button, and this is going live. New documentation, and you can start using those tomorrow. Verbs history. So this is a first-party package that we've created for Verbs, which allows you to say, any model that I've event-sourced using Verbs, I can get full detailed history of everything that happened to that model. So this task was assigned to this user. Then this task was added to this project. Then this task was estimated to be an extra large t-shirt size. All of those little events that happen to a thing over time, we're going to show you history in line of what happened to that thing. And we're even giving you a blade component to display those things. So this has been running in our client apps, in both client apps, consistently for a month in production. It's good. It's packaged up. It's its own package, and we're pulling it into our apps. We just need to fix the documentation a little bit before we put it out, so that's coming out later this week. Verbs commands is our second big first-party package. This is not launching this week, but it is launching soon. So Verbs commands is really awesome because every event wants to be a command, right? So if you say, let's come up with an event, like task assigned to user, right? A task assigned to user event really wants to be a assign task to user command, right? And so what we've created is a mechanism to know for a given model what tasks are available on that model, what input is required to execute those tasks. So I might need to know which user to assign a given task to. And we're also creating a Livewire command palette component that allows you to execute those commands in line, and you get keyboard shortcuts. So all of that is coming soon, like a month-ish, I don't know. But yeah, that is it for now. That's everything I have to announce to you right now about Verbs. I would love to talk to any of you about event sourcing, so I'm around, and you can come ask me questions or just talk to me, tell me your horror stories. I'd love to hear them. Anyway, thank you very much. GG. Have a good day.
So I also have two questions for you.
Okay, let's hear them.
Yeah. So first question about India.
Yes.
Since it's your first visit, right?
Yes.
So how has been feeling of India, and especially like what has been the cultural differences between both the countries?
Oh, the traffic is just great. I love the traffic.
Did you love the traffic or the chaos?
I love the chaos, yeah. At no point have I felt like I was going to die in an auto rickshaw. No, but seriously, I love India. It's not the same. Everything is a little bit different. Every place you go is a little bit different. Every person you talk to is a little bit different. So I love it.
Yeah.
And the food's excellent.
Question, yeah. And second question, like you've been speaking, also you're running a company, also you're doing a podcast. So like sometimes, doing a lot of things at the same time. So that multitasking sometimes becomes tricky, where you cannot prioritize. So how do you manage multitasking, which can create an impact for us?
So yeah, it is tricky, and it's very hard to do. Fortunately, so I have a business partner at Thunk named John, and John is like an incredibly disciplined and focused person. I am like a crazy person. John is a very disciplined and focused person, and so I would not be able to do all of the many things I do and successfully run a business if I didn't have such a good business partner.
Yeah, perfect. Thank you, Daniel.
Awesome.
Yeah.
Thank you.
Thank you.